This video covers section 8.5, and in it we will learn how to solve systems of equations, now involving 3 equations and 3 variables, and then we will also learn how to set up a system of equations for applications that involve 3 variables. So here's our first example.
Alright, so let's look at a new type of problem here. Here we have a 3 by 3 system. Instead of having the usual that we're used to, 2 equations with 2 unknown variables, we now have 3 equations with 3 unknown variables. And the thing is it's really a lot of the same processes. We just have a preliminary step which makes our problem like the older problems that we already know how to do. So our goal here, if you will, our goal is to turn the 3 by 3 system, 3 equations, 3 unknowns, into a 2 by 2 system that we already know how to solve. And it's a pretty lengthy process, so let's go ahead and start here with step 1. Step 1 is that we want to eliminate the same variable from 2 different pairs of equations. So if I'm looking at this problem, I might choose to eliminate the variable y, because I noticed that 4 and 6 are both multiples of 2, and we're going to eliminate the exact same way that we did in the 2 by 2 problems. We're going to use the elimination method. So if I call this equation 1 and equation 2 and equation 3, if I take equation 1, again, equation 1 is the 3x plus 2y plus 5z equals negative 8. And I take equation 2, the 9x minus 4y plus 6z equals negative 38, and I multiply the top equation by what? I multiply it by 2, then the top equation becomes 6x plus 4y plus 10z equals negative 16. And the bottom equation I don't want to touch, because right now if I add it to this changed first equation, I'm going to see stuff start to cancel out. So if I add, the x's make 15x, the y's cancel, I get plus 16z equals, what's that, a negative 54. Okay, and that's a new equation. Let's call this equation 4. Notice it only has 2 variables in it. Now in step 1, notice I said eliminate the same variable from 2 different pairs of equations. So let's now, instead of using equations 1 and 2, let's use equations 1 and 3. 3x plus 2y plus 5z equals negative 8, and 9x, equation 3 is negative 6x minus 6y plus 7z equals negative 62. And what do we want to multiply the top equation by? We want to multiply it by 3. Don't change the bottom one. And we multiply the top equation by 3, we get 9x plus 6y plus 15z equals negative 24. The bottom equation is still negative 6x minus 6y plus 7z equals negative 62. And if I add, I get 3x, the y's cancel again, plus 22z equals negative 86. We have another new equation. Let's call this equation 5. Okay, so now we're down to step 2. Step 2, we've got our two new equations with two variables. So we want to solve this new 2 by 2 system, which we already know how to do. We want to solve equations, we want to take equations 4 and equations 5 and solve them. So let's rewrite them here. Equation 4 was the 15x plus 16z equals negative 54, and then equation 5 was the 3x plus 22z equals negative 86. And what do we need to do to be able to solve this? Well, I think the easiest thing to do is to take the bottom equation and multiply it by negative 5. Multiply by negative 5. Don't change the top one. The top one we'll leave as 15x plus 16z equals negative 54. But the bottom one is now going to be negative 15x, because 3 times negative 5 is negative 15. And then 5 times 22 is negative 110z. And then 5 times 86 is 430. It's going to be a positive 430. And now we can go ahead and add, because as you can see the x's cancel, and if I add 16 to negative 110, I get 94z. And if I add negative 54 to 430, I get 376. This was a negative 94z. And then if I just divide that by negative 94, we get what? We get negative 4. So we get z is equal to negative 4. Alright, so we got our first variable. Now we still haven't finished solving this 2 by 2 system because we only know what z is. We also need to figure out what x is. So remember, we can just take this and plug it into either of the two equations. If I plug it into equation 5, I'm going to have 3x plus 22 times a negative 4 is equal to negative 86. And of course 22 times negative 4 is a negative 88. So we have 3x minus 88 equals negative 86, which if I add the 88 over the other side, I get 2 on the right hand side. So that's going to give me 3x equals 2, which means x equals 2 over 3. So you probably guessed by now that if you want to figure out the final variable, variable y, we can just take x and z and plug it back into one of the original equations. And so it doesn't really matter which one we choose. We could choose equation 2, equation 3. Let's go ahead and choose equation 3 here. If I take 3, and which is negative 6x minus 6y plus 7z equals negative 62, and I plug the 2/3 in for x, and I plug the negative 4 in for z, that's going to be negative 6 times 2/3 minus 6y plus 7 times negative 4 is equal to negative 62. Negative 6 times 2/3 is a negative 4 minus 6y minus 28 equals negative 62. And then combine like terms, I get a negative 6y minus 32 equals negative 62. If I add 32 to the other side, almost done here. That's going to give me a negative 30 over here is equal to a negative 6y. And then of course if we divide by negative 6, we're done. We got that y is equal to 5. Sorry. Final answer, if we write it as an ordered triple this time, not an ordered pair, because we have 3 parts to our solution. We have x is 2/3, we have y is 5, and z is negative 4. So besides being able to solve one of these by hand, we also need to be able to look at different applications involving systems of equations. And that's what we're going to do in the next few examples. We're not going to solve them all the way out because we've just gone over how to do that. We're just going to set them up. So let's move on and try one of those. Let's read through the problem, see what's given, see what we're trying to find. It says Abraham, that's one of the things that's given. Abraham is 8 years older than Belen, and the sum of Belen's age and Celeste's age is 3 years more than twice Abraham's age. It says if the sum of their ages is 138, how old are Abraham, Belen, and Celeste? And we're going to approach this the exact same way we did the previous application problems we looked at. We're going to start out by writing out some variables. We're going to define variables. And in this case, I think it makes sense to use A, B, and C. A being Abraham's age. B defined as Belen's age. And then C defined as Celeste's age. And we're given some information. Now remember, we're trying to come up with 3 equations. This first part that's highlighted in yellow is actually an equation. It says Abraham is. Well, Abraham is A. Is stands for equals, so we're going to have A equals 8 years older than Belen. Belen's age B plus 8. There's our first equation. Okay, let's look at the second part highlighted in yellow. It says the sum of Belen's age and Celeste's age. The sum, that means addition. Sum means addition. Belen's age plus Celeste's age is, there's that is word again, that means equals. So B plus C equals 3 years more than means plus, twice means 2 times. So this is going to be 3 plus twice Abraham's age, twice A. There's a second equation. And the last one, it says the sum. That means their total age, all 3 people, is 138. So A plus B plus C equals 138. Again, we're going to just talk about now setting this up. We will talk about solving this a little bit later. But let's take a look at another example here. The measure of 3 angles of a triangle must total 180 degrees. We're given that. Measure of angle A is 15 degrees more than B, and the measure of angle B is 15 greater than 4 times the measure of C. What are we trying to find? The measure of each angle. So let's start off with our variables. A is the measure of angle A. You may remember from geometry this symbol right here means angle. B is the measure of angle B, and C is the measure of angle C. What are our equations? Well, let's go through and see what's given. The measure of the three angles must total 180. That means A plus B plus C must equal a total of 180. I hope you're getting used to writing those type of equations. We also have a couple sentences that describe other equations. It says the measure of angle A. A is, there it is again, A equals 15 more than angle B. Again, more than means plus. So that means it's going to be angle B plus 15, or 15 plus B. Next sentence, the measure of angle B is B equals 15 degrees greater than 4 times the measure of angle C. So 4 times angle C plus 15. 15 degrees more than 4 times C. Or you could have written it B equals 15 plus 4C. It doesn't matter which way we write those in. It really doesn't matter. Same thing here. This could have been 15 plus B. Again, there's our equations. We'll talk about solving them later, but that's how you go ahead and set this up. Let's talk about the next one. A chemist wants to mix 3 different solutions to create 100 milliliters of a solution that is 13.5% alcohol. Solution A is 10%, B is 15% alcohol, and C is 30% alcohol. And then it says the amount of solution A is used must be twice the amount of solution B that is used. And finally, how many milliliters of each solution must the chemist use? A is the milliliters of solution A. B, milliliters of solution B. C, milliliters of solution C. We already did one like this with the 2x2 systems. What we know is the chemist wants to mix a total of 100 milliliters. That means that the amount of A plus the amount of B used plus the amount of C, the amount of A, B, and C mixed together must add up to 100 milliliters. Okay, and then we're going to talk about how much alcohol is actually in there. Well, the amount of alcohol is going to be, the mixture is 13.5%, and we want 100 milliliters, so it's going to be 13.5 milliliters of alcohol. This part right here comes from 100 milliliters times 0.135 times the 13.5%. And this comes from taking 10% alcohol times A milliliters of solution A plus 15% times B milliliters of solution B plus 30% times C milliliters of solution C. There's our second equation. And the final one says the amount, this is the third sentence, the amount of solution A that is used must be twice the amount of solution B that is used. A must be equal to twice the amount used for solution B. And again, we could solve this system using methods talked about earlier in the notes. Okay, Thank you.